Imagine I have two coins. I flip both, and somehow, impossibly, when one lands heads, the other instantly lands tails, every single time, no matter how far apart they are. Not because they're communicating, not because there's a hidden signal passing between them, but because they're entangled, sharing a single quantum state that transcends space itself. This isn't a magic trick. It's quantum entanglement, and it's real. Right now, in laboratories worldwide, scientists are creating pairs of particles that remain mysteriously connected, regardless of distance. Measure one, and you instantly know something about the other, even if it's on the other side of the galaxy. The measurement doesn't send a signal. It can't, because that would violate the speed of light. Instead, the particles share a unity that defies our everyday intuitions about reality. Einstein called it spooky action at a distance, and he meant it as criticism. He was convinced that quantum mechanics must be incomplete, that there had to be hidden variables, information we couldn't see, that explained these correlations without requiring instantaneous influence across space. But decades of experiments have proven Einstein wrong on this point. Entanglement is real, it's been measured countless times, and it reveals something profound. The universe is fundamentally non-local. Particles that were once together remain connected in ways that transcend our classical understanding of separate objects existing in different locations. In 1935, Einstein, along with Boris Podolsky and Nathan Rosen, published a paper arguing that quantum mechanics couldn't be a complete description of reality. Their EPR paradox, as it became known, highlighted entanglement as evidence that something was missing from quantum theory. How could measuring one particle instantly affect another across vast distances without any signal passing between them? Either information was traveling faster than light, violating relativity, or quantum mechanics was incomplete. For decades, this remained philosophical debate. Then, in 1964, physicist John Bell developed a mathematical test that could distinguish between Einstein's local hidden variable theories and quantum mechanics' prediction of genuine non-local correlations. Bell's theorem showed that if local realism is true, if objects have definite properties independent of measurement and influences can't travel faster than light, then certain statistical correlations between measurements have limits. The experiments came next. Starting in the 1970s and continuing through increasingly sophisticated tests today, physicists have measured these correlations. The results are unambiguous. Quantum mechanics wins. The correlations between entangled particles exceed Bell's limits, ruling out local hidden variable theories. The universe really does exhibit non-local connections. Entanglement isn't a glitch or gap in our knowledge, it's a fundamental feature of reality. Now entanglement is moving from physics labs into technology that will transform civilization. Quantum computers exploit entanglement to perform certain calculations exponentially faster than classical computers. While a normal computer processes bits in sequence, a quantum computer uses qubits that can exist in superposition and become entangled, allowing it to explore vast numbers of possibilities simultaneously. Problems that would take classical computers millennia, like factoring large numbers, simulating molecular interactions, or optimizing complex systems, could be solved in minutes by quantum computers. Google, IBM, and others are racing to build practical quantum computers, and we're already seeing quantum advantage in specific tasks. Quantum cryptography offers truly unbreakable security. When you send encryption keys using entangled photons, any eavesdropping attempt disturbs the entanglement, immediately alerting you to the security breach. China's Mikias satellite has already demonstrated quantum key distribution over 1,200 kilometers, creating hack-proof communication channels. Banks, governments, and military organizations are investing heavily in quantum encryption networks. Quantum teleportation, don't worry, we're not beaming people yet, allows transferring quantum states between particles using entanglement. While you still need classical communication, preventing faster-than-light information transfer, quantum teleportation enables quantum networks where information can be processed and transmitted in fundamentally new ways. The deeper implications of entanglement extend beyond technology into the very nature of reality. Some physicists propose that entanglement might be the fundamental building block of space-time itself. In this view, the geometry of space emerges from patterns of quantum entanglement, like how temperature emerges from molecular motion. Space isn't a container that particles exist within. It's a phenomenon arising from quantum correlations. The holographic principle suggests our universe might be like a hologram, with all information contained on a distant boundary, and entanglement provides the mechanism. The ER equals EPR conjecture proposes that quantum entanglement might be equivalent to microscopic wormholes connecting particles, that Einstein's theory of curved spacetime and quantum entanglement might be two descriptions of the same phenomenon. Some interpretations of quantum mechanics suggest entanglement connects not just particles, but entire universes. In the many worlds interpretation, quantum measurements create branching realities, and entanglement might link these parallel worlds. While highly speculative, these ideas illustrate how profoundly entanglement challenges our picture of reality. Consciousness researchers even explore whether quantum entanglement plays a role in the brain, potentially explaining the unity of conscious experience. While controversial and unproven, the hypothesis suggests that the binding problem, how separate neural processes create unified awareness, might involve quantum coherence and entanglement, the universe's most mysterious phenomenon, meeting the mind's deepest mystery. Looking forward, we stand at quantum technology's dawn. Within decades, we might have quantum internet spanning the globe, with quantum repeaters and satellites distributing entanglement, enabling instant secure communication, and distributed quantum computing power. Quantum sensors using entanglement could detect gravitational waves from the universe's birth, map brain activity with unprecedented precision, or probe the quantum structure of space-time itself. Entanglement might help us detect dark matter, understand dark energy, or reconcile quantum mechanics with gravity, solving physics' biggest puzzle. It could revolutionize drug discovery by simulating molecular interactions, design new materials by modeling quantum properties, or optimize everything from traffic flow to financial markets. But beyond practical applications, entanglement reveals something profound about existence. We live in a universe where connection is more fundamental than separation, where what appears separate remains unified at the deepest level. Every particle that's ever interacted carries traces of that connection forward through time. In a real sense, everything that's ever touched remains entangled, creating an invisible web connecting all of reality. This isn't mysticism, it's physics, but it suggests that the universe is far stranger, far more unified, far more beautiful than our everyday experience reveals. As we learn to harness entanglement technologically, we're also learning to see reality as it truly is. Not a collection of separate objects, but a unified whole, where everything connects to everything else through quantum correlations, transcending space and time. The quantum revolution has just begun. The secrets we unlock through entanglement will reshape technology, transform our understanding of reality, and perhaps reveal that the universe's deepest truth is connection itself. We're all part of this cosmic web, entangled with everything that's ever touched us, bound together in the universe's quantum fabric. And now, finally, we're learning to read the universe's secret language and speak it back.